Students, today we will discuss 50th group of elements, which is also known as nitrogen family. In this particular lesson, some important questions and which are expected from the future entrance exams. Coming to question number 1, in nitrogen family, the HMH bond angle in their hydrides gradually becomes closer to 90 degrees. What is the reason for this? That is the question. Talk about HMH bond angle is saying, either we consider in this particular NH3, phosphine, orosine, stibine you take, stibine. Here it is found to be nearly 107 degrees. This is around 94. This is around 92. This is around 91 degrees. Why there is decrease in the bond angle? That is the question. So top to the bottom, they are all involving actually sp3. Top to the bottom, the sp3 hybrid orbitals, the atomic size is increasing. The atomic size is increasing. The sp3 hybrid orbitals character is decreasing. sp3 hybrid orbitals character is decreasing. So pure p orbitals are actually involving in bonding. Therefore, top to the bottom, the bond angle is coming to be near to 90 degrees. Let us see the options. The basic strength of hydrates increases. There is no relation between bond angle and basic strength. Coming to B, almost pure orbitals are used for MH bonding. So top to the bottom, what I said, the pure p orbitals are, the participation of p orbitals increasing, I said. Coming to C, the bond energies, there is no relation between bond energy and bond angle. Coming to D, the bond pairs of electrons are become further apart from the central atom. That is also not the suitable reason. Only the reason is what? The sp3 hybrid orbitals character is decreasing and atomic p orbitals are involving in bonding. That is the suitable reason for this question. Therefore, the question number 1 answer is B. Question number 2, most acidic oxide is. Option A is given as what? Arsenic oxide. Arsenic oxide. Option B is given as what? P2O3. Option third is given as what? Sb2O3, Sb2O3, Bi2O3. Question is that which is among these most acidic. Acidic means there should be a non-metallic oxide. This is what? Metalloid, arsenic. This is also metalloid. This one is what? Purely metal. These two are metalloidic oxides. They are amphoteric in nature, not much acidic. Coming to phosphorus trioxide. Phosphorus trioxide is what? Non-metallic oxide. Moreover, suppose you are talking about P2O3 with water, produce what? Phosphorus acid. As it is producing with water, acidic solution, a acid it is producing. Therefore, among the given A, B, C, D, for second question answer is only answer B. Question number 3, when lead nitrate is heated, it produces. Let us see what are the products. A is given as NO2, B is NO, and C is N2O5, and D is what? N2O. These are the options. Let us see lead nitrate. Lead nitrate on heating, look here, it is actually decomposing to produce 2 PbO, 4 NO2 plus O2. The product is actually NO2. So here NO2, NO, N2O5, N2O. Therefore, the question number 3 answer is A. Coming to question number 4. Question number 4. Rainwater sometimes contains ammonium nitrate because lightning in the sky causes the air to react and produce oxides of nitrogen, and lightning, nitrogen and oxygen are combining. What are the options given? Check it. A, hydrogen gas. B, ammonia gas. C, CO2. D, noble gases. During the lightning actually N2 plus O2 lightening nearly 3000 degrees centigrade, then you are getting NO. Along with this particular NO, there is a formation of trace amounts of N2 combined with hydrogen producing ammonia gas also, producing ammonia. N2 plus H2 combining, giving rise to ammonia gas. Some amount of, little amount of ammonia is also formed. This is also possibility of formation of ammonia. Therefore, rainwater sometimes contains ammonium nitrate because lighting in the sky causes the air to react and produce oxides of nitrogen and ammonia. Once ammonia is produced, ammonia reacts with again nitrates or the HNO3 formed in the atmospheric air. Then ammonia reacts with the HNO3 forming ammonium nitrate. Therefore, question number 4 answer is B. Question number 5. Which is the most thermodynamically stable allotropic form of phosphorus? Among the allotropic forms of phosphorus, different types are there: red, white, black, etc. Which is thermodynamically more stable? Coming to option A, red phosphorus, white phosphorus, black phosphorus and yellow phosphorus. So, only black phosphorus actually possesses layered structure. It resembles structure with graphite. It is thermodynamically more stable allotrope of phosphorus is black phosphorus. Possesses layered structure, resembles graphite structure. So, it is also a conductor. So, question number 5 answer is C. Question number 6. White smoke is formed when ammonia gas meets with A. Water, B. HCl, C. H2SO4, D. HNO3. Suppose ammonia plus water, what to get? Simply ammonium hydroxide. Ammonia plus HCl, you are getting ammonium chloride. You might be knowing this particular ammonium chloride is white thick fumes. White thick fumes of ammonium chloride whenever ammonia reacts with what? HCl. Coming to option C, sulfuric acid. Sulfuric acid producing ammonium sulfate. It is not giving any fumes. And HNO3 gives ammonium nitrate. That is also not fumes. So, white smoke is formed, white fumes, thick white fumes or white smoke is formed whenever ammonia reacts with HCl. Therefore, for the 6th question, answer is B. Question number 7. Liquid ammonia is used in refrigerators because we prefer to use liquid ammonia in the refrigerators because a high dipole moment. There is no relation between dipole moment and using that particular liquid ammonia in refrigeration. Coming to B, it has high heat of evaporation. C, of its basicity. D, of its stability. Stability, basicity and dipole moment not useful as the liquid ammonia acting as what? Refrigerant. But only it's a high heat of evaporation. High heat of evaporation is the reason because it is easily evaporated, so that it can easily cause cooling effect. Therefore, high heat of evaporation is the answer for this. So, for question number 7, answer is B. Question number 8. Pure N2 can be obtained by A. Heating barium azide, B. from liquid atmospheric air, C. both, D. none. See, there are many methods to prepare this particular nitrogen gas. One is from ammonium nitrate, second is from commercially nitrogen gas they actually produce from liquid atmospheric air, and again barium azide or sodium azide on heating also getting nitrogen gas. But often question appears, which of the following represents the preparation of pure nitrogen gas? Only from azides. Now we take barium azide. giving rise to BA, and you are getting N2 gas. BA N2 gas. This like this, you are getting N2 gas. This particular N2 gas, whatever is produced, will be highly pure form. So far, question number 8, answer is A. Question number 9, ammonium chloride is used to clean metal surfaces because generally metal surfaces for cleaning we use ammonium chloride. What is the reason behind it? It dissociates into ammonia and HCl on heating. B. NH2 forms a soluble complex with metal. C. Ammonium chloride forms a volatile chloride. D. None of this. Ammonium chloride dissociates into ammonia and HCl. HCl is actually acid, and again ammonia is what a base. The base and acid can easily clean any dust, any oxide layer on the surface of the metal. Therefore, the 9th question, it dissociates into ammonia and HCl on heating. Question number 9, answer is A. Question number 10, ammonium dichromate is used in some fireworks. The green colored powder blown is A. CrO3, B. Cr2O3, C. Cr, D. CrO2. See, ammonium dichromate, this is very important. Ammonium dichromate. NH4 taken to ice, Cr2O7. On heating this, look here, N2 gas you are getting Cr2O3, and you are getting, this is actually grey green ash we call, grey green ash, grey green ash. This particular ammonium dichromate is generally used to demonstrate volcanic eruption. It actually, whenever on heated, it explodes just like flower pot. How the way the flower pot is actually exploding, how the volcano is actually exploding, similar way this ammonium dichromate is exploding. The explosive property is due to the spraying of this particular Cr2O3 grey green ash due to formation of N2 gas. What is given? The green colored powder. The green colored powder is this particular Cr2O3. So for question number 10, answer is B. Question number 11. Man dies when nitrous oxide is inhaled in large quantities because is poisonous, causes laughing hysteria, decomposes hemoglobin, reacts with the organic tissues in the body. So man dies when nitrous oxide. See, nitrous oxide, N2O. We call it what commonly it is laughing gas. Commonly known as laughing gas. It is little poisonous. It stimulates or affects the brain, which is actually stimulating the laugh. Therefore, man dies when nitrous oxide inhaled in large quantities you are inhaling. So it actually causes laughing hysteria. Therefore, question number 11, answer is B. Question number 12. Nitrous oxide when easily be distinguished from nitric oxide by A. Adding water and shaking, introducing a glowing splint, mixing with some air, adding some hydrogen. See, how you distinguish between a container carrying NO, a container carrying N2O? This is the question. See, first one is adding water and shaking. Adding of water to both of these, there is no much difference. Both are neutral oxides. Both are neutral oxide, no much change if you are adding water. Both are behaving similarly. By introducing a glowing splinter you are putting a mastic, a burning mastic you are putting into that. Both are actually non-combustible. They do not support combustion. that is putting off. Either you take this, both are actually putting off, extinguishing the burning splint. Coming to mixing with some air, see NO plus oxygen, then you are getting 2NO2. How we are getting this? Now 2NO plus oxygen, you are getting what? 2NO2. But once you are actually mixing oxygen, N2O will not react with this particular oxygen. Here no reaction, but is actually producing NO on reaction with oxygen or air, producing what? NO2, which is brown in color, brown gas. Here you see NO is with the air producing brown gas, brown color, but is not producing any brown color. By this we can easily distinguish which is NO vessel, which is N2O vessel. You can easily distinguish. So, for the question number 12, answer is C. Question number 13. When heated to 800 degrees centigrade, N2O gives A. NO plus O2, B. NO2 plus O2, C. N2 plus O2, D. None of this. C. N2O. At little higher temperature, more than 500 degrees centigrade, is given as what? 800 degrees centigrade. Yes, actually it is decomposing to produce N2NO2. Completely decomposes to produce N2NO2. N2NO2. So, question number 13, answer is C. Question number 14. Molecule with a 3 electron bond is A. Cl2 molecule, B. NO, C. H2O, D. Cl2O. So, if you talk about this particular NO, is actually carrying what? Odd number of valence electrons. Nitrogen valence electrons are 5, oxygen valence electrons are 6, total coming to what? 11 valence electrons. See, generally, a molecule actually carrying odd number of valence electrons. One of the unpaired electron remain over the molecule or involving in a 3 electron bond. Look here in the case of NO, there is actually 11 valence electrons are involved here. 11 valence electrons. Therefore, one of the electron involving in 3 electron bond. In the case of NO, the bonding is like this. A double bond, 2 electrons from nitrogen, 1 electron from oxygen. It is gaining what? A plus charge, a electron. This is actually bonding in this particular nitrogen. Nitric oxide is carrying what? A 3 electron bond. So, 14th question, answer is what? B, nitric oxide. Question number 15. Dinitrogen tetroxide N2O4 is a mixed anhydride because it is a mixture of N2O3 and N2O5 decomposed into 2 oxides of nitrogen. So, it reacts with water to form nitric acid, reacts with water to form 2 acids. See N2O4. Water producing mixture of oxyacids H1O2 and H1O3. Whereas nitrous acid, the other one is what? Nitric acid. Therefore, we can consider as it is producing what? Mixture of 2 oxyacids. Therefore, reacts with water to form 2 acids. Therefore, question number 15, the answer is what? Mixed anhydride of nitrous and nitric acids. Therefore, 15th question, answer is D. See question number 16, the gas obtained when urea reacts with the nitrous acid is. Option A is given as N2, option B is NO, option C is N2O, and D is what? NO2. Let us see what is the reaction between urea and nitrous acid. Urea plus nitrous acid gives rise to 2N2, 1 CO2 molecule, 3 H2O. This is the reaction between urea and nitrous acid. See what is the main product you are getting? N2. So, N2, NO, N2O, NO2. So for the question number 16, the answer is what? A. Question number 17. Passing H2S gas through nitric acid produces. This is a good question. I have seen many times this particular question. What type of allotropic form? What type of allotropic form is forming whenever H2S gas is bubbled into HNO3? A. Rhombic sulfur. B. Monoclinic sulfur. C. Colloidal sulfur. D. Plastic sulfur. See what is the reaction between these two. Take H2S gas, nitric acid, you are getting sulfur precipitate, and also you are getting 2 NO2 plus 2 H2O. Sulfur you are getting as a precipitate. This particular sulfur is actually colloidal sulfur. So question number 17, answer is C. Colloidal sulfur is produced when H2S gas interacts or reacts with the HNO3. Answer is C. Question number 18. Skin turns yellow when in contact with constant HNO3 because, see, whenever in the laboratory while doing a practical, by any means HNO3 actually coming in contact with skin. Wherever the HNO3 is actually coming in contact, that particular part turns to yellowish in color. What for it is due to? A. Proteins are converted into xanthoproteins. B. Water is removed by the acid. C. Skin gets burnt. D. Nitrocellulose is formed. Skin, whenever coming in contact with HNO3, forming a nitroprotein. The nitroprotein what we call xanthoprotein. So 18. Skin turns yellow in contact with constant nitric acid is only due to formation of xanthoprotein, a nitro compound. So 18th question answer is A. Question number 19. The catalyst used in the manufacture of HNO3 by Ostwald's process. A. Platinum black. B. Finely divided nickel. C. Vanadium pentoxide. D. Platinum gas. Generally, vanadium pentoxide used in contact process. Platinum gas is generally used in Ostwald's process. See, 19th question. In Ostwald's process, in the manufacture of HNO3, we use platinum gas, a platinum net we are using. So, question number 19, answer is D. Question number 20, which is used to produce smoke screens? Calcium phosphide, sodium carbonate, zinc phosphide, zinc sulfide. Now we talk about calcium phosphide, Ca3P2. This is actually in the moisture, any amount of moisture is there, undergoing hydrolysis, producing calcium hydroxide and phosphine gas. This phosphine gas carry trace amounts of diphosphine. What to say this is? Diphosphine. Diphosphine easily converts into this phosphorus dioxide, P4O6. P4O6 what? A thick cloud. P4O6 is a thick cloud or thick smoke. So it is acts as what? A smoke screen. Acts as a smoke screen because of formation of P4O6. The P4O6 is due to what? P2H4. So calcium phosphide producing phosphine and trace amounts of P2H4. P2H4 when comes in contact with the air, that is converting into what? The oxide P4O6. P4O6 actually a thick cloud. That is the reason why we are getting a smoke screen. Therefore, 20th question answer is A. Question number 21. Phosphorus when exposed to air burns spontaneously because the reaction is endothermic. B. Reaction is exothermic. C. The activation energy is very low. D. Air contains some catalytic agent. Well, if phosphorus exposed to air, actually white phosphorus when exposed to air catches fire. This generally we call it what? Pyroporic nature. White phosphorus is pyroporic. any substance which is catching fire in the atmospheric air, we call it pyroporic. This white phosphorus is actually pyroporic. Whenever exposed air catches fire, this is only due to what? Its activation energy is what? Very less. Therefore, question number 21, answer is C. Question number 22, mixture used on tips of matchstick. Matchsticks is tip of the matchstick. Tip of the matchstick carrying what are the substances? Now, sulfur and potassium, only sulfur and potassium are there, they won't burn properly. Antimony sulfide. C. Potassium dichromate, sulfur and red phosphorus. D. Potassium dichromate, potassium and sulfur. The tip of the matchstick generally carrying potassium dichromate, which is strong oxidizing agent, potassium dichromate, and sulfur helps in burning, then red phosphorus. So, these are substances, matchstick, the tip of the matchstick carrying potassium dichromate, sulfur and red phosphorus. Question number 22, answer is C. Question number 23, a cold green flame can be made by passing CO2 over warm branch, white phosphorus, gratin, green candles. Whenever CO2 is passed through white phosphorus, over this you are passing CO2 gas. That is actually burning a cold green flame. Cold green flame. Cold green flame, the green flame is not so hot. Therefore, we call it what? Cold green flame. So, phosphorus in presence of this particular CO2 gas, it burns with a cold green flame. So, question number 23, answer is what? B. Question number 24, the metallic form of phosphorus is, see different allotropic forms are there, white phosphorus, red phosphorus, black phosphorus. In this particular black phosphorus, beta black is there, alpha black is there. See, black phosphorus 2, beta black and alpha black, but beta black is only actually possessing a layered structure, resembling its structure with graphite. Like graphite, this particular beta black is conductor. Therefore, metallic form of phosphorus, once it is conducting, therefore exhibiting metallic property, therefore let us take question number 24, answer is C. Question number 25, good conductor of electricity is yellow phosphorus, red phosphorus, violet phosphorus and black phosphorus. See, black phosphorus generally alpha and beta black phosphorus are there, but beta black phosphorus, it is having a layered structure like graphite, resembles in structure with graphite, and it is actually conducting electricity like graphite. Therefore, good conductor of electricity. So, answer is D, black phosphorus. Question number 26. Phosphorus pentoxide cannot be used to dry. A. Nitrogen, B. Ammonia, C. Hydrogen sulfide, D. Sulfur dioxide. See, phosphorus pentoxide reacts with only ammonia gas. Ammonia may react with this particular phosphorus pentoxide. Therefore, this particular phosphorus pentoxide is generally not used for drying of ammonia gas. Therefore, 26 answer is B. Question number 27. Phosphorus pentoxide has short and long PO bonds. The number of short PO bonds in this particular compound. See, option is what? 1, 2, 3, 4. Then you should know the structure of this particular compound, P4O10. Oxygen. There are actually these are bridged oxygens. doubly bonded. These are having double bond character. Then 4 terminal oxygens are their PO bonds. Definitely this is single, this is double bond. Definitely the terminal PO bonds are having double bond character. Therefore, 27 P4O10 is carrying 4 such short PO bonds. Question number 27, answer is D. Question number 28. Gram salt is sodium aluminosilicate, B. Sodium hexametaphosphate, C. Ferrous ammonium sulfate, potassium chromium sulfate. Gram salt is sodium hexametaphosphate to take. This is what you call NaPO3 taken 6 times. Sodium hexametaphosphate. This sodium hexametaphosphate commonly known as Graham salt. So question number 28, answer is B. Question number 29. Which acid has PP linkage? Option is hypophosphoric acid. See what is the formula and structure you should know. P2O6. In this particular, the structure of this particular hypophosphoric acid. Next, pyrophosphoric acid. H4P2O7. See in this, phosphorus and phosphorus are bridged by oxygen atom. H4P2O7. Metaphosphoric acid, HPO3. HPO3. Orthophosphoric acid, so in this particular 29, phosphorus to phosphorus only, a bond is there in hypophosphoric acid. So question number 29, answer is A. Question number 30. Solid PCl5 exists as only PCl5? No, PCl5 is not that stable, therefore it exists in a different form. B. PCl4 plus, C. PCl6 minus, PCl4 plus and PCl6 minus. Look here, PCl5 in solid state, existing as PCl4 plus and PCl6 minus. PCl4 plus and PCl6 minus. Because PCl5 is a trigonal bipyramid, it is not stable. Therefore, it is actually in this way it is existing. One is tetrahedral, one is octahedral. Therefore, PCl5 in solid state exists in this particular ionic form. Therefore, question number 30, answer is D. Question number 31. The fertilizer named nitrolim is prepared by the use of A. Calcium oxide and plus N2, calcium carbide, CaC and N2, CaC2 and N, CaC2 and N2. Now you talk about CaC2 plus N2. This to be in an electric furnace. Means at very high temperature. Then you are getting CaCN2 plus C. This particular mixture CaCN2 calcium cyanamide plus C. This particular mixture we call it as commonly nitrolim. This particular CaCN2 plus C mixture is used as what? A fertilizer. So question number 31, answer is D.